ये आपने बिल्कुल समझ। जी बताइए।
I don't have doubt मगर like बहुत ज्यादा प्रैक्टिस करनी है।
क्या बहुत ज्यादा प्रैक्टिस नहीं किया? देखिए इस टेबल को ना बहुत अच्छे तरीके से समझने की कोशिश
Yeah.
कीजिएगा।
जी।
ठीक है है ना। और खास तौर से ये चीजें जैसे फॉर एग्जाम्पल स्पेशली दिस स्टेरिक नंबर 4 एंड स्टेरिक नंबर 5 इज वेरी इंपॉर्टेंट। ठीक है। स्टेरिक नंबर 4 में किस तरह से जब आपके पास जीरो लोन पेयर है देन वी आर हैविंग द शेप एज टेट्राहेड्रल, but when we are having one lone pair it becomes triangular pyramidal, and when we have two lone pair it becomes bent, है ना। Similarly in sp3 we have trigonal bipyramidal, then it becomes seesaw if there is one lone pair, है ना? And t shape when there is two, right? So also one more thing in sp3d is the structure of pcl5, that is very important. Okay, so these two, steric number 4, steric number 5, like each and every case is very important in these two. Okay.
Yes sir.
ठीक है। हर्षा, how are you?
I'm good, sir. How about you?
Yeah, I'm also good. So Harsha, you were not present in the last class, right?
Yes, sir.
What happened?
Sir, I was outside, so I couldn't attend.
Sorry?
Sir, I was outside, so I couldn't attend.
You were outside. So did you watch the lecture?
Yes, sir.
You understood everything? Any doubt?
No.
Okay. Well, you will start in 3 minutes, okay? Start in 3 minutes. Oh, Sadika is also here. Assalamu alaikum, Sadika. How are you?
Walaikum salam, sir. I'm good, alhamdulillah. How are you?
I'm good. I'm good. Alhamdulillah. And were you present in the last lecture?
No, sir. I've missed the past 2 weeks of classes.
So did you watch the lectures?
Sir, I got the videos. I just need to watch them.
No, you just got the videos, and now the bigger work is to watch them. Getting the video
Yes,
was not
sir.
a big work. है ना? So you have
Yes.
just got the, yeah.
Sir, I just
You
came
have-
back from Umrah, so I'm still unpacking.
Acha. Okay, fine. And there's a lot of crowd, na? Even now.
Yes, sir. When we went, there was a lot of people than we expected.
Yeah, I have like one of my
They
cousins
opened the
also went. Tell me.
yes. No, they opened the international flights as well. So there were a lot of groups compared to just a week before we left.
Acha. Yeah, I mean, I saw some videos of like Safa and Marwa. It almost like it was like Hajj only.
Yes, sir.
Okay,
It wasn't
fine.
as crowded in the afternoon as in the evening.
Okay, fine. Is it still? It would be hot there, na? Because you are having summer vacations, so obviously there will be hot right now.
Yes, yes, sir.
Yeah. Okay. So in the last lecture, we completed the static number 2, 3, 4, 5, and 6. Now there is one special case, that is the case of DSP2 hybridization. There is not much in the class 12, sorry, in the class 11, but DSP2 hybridization for static number 4, it is present in the 12th standard, but it is mentioned in the NCERT about DSP2. So we will understand what is the DSP2 hybridization, and then we will move on to the main topic of today's class, that is bond parameters. Okay, so please write the topic DSP2 hybridization. DSP2 hybridization. First point, found majorly in compounds formed by D block elements. D block elements. So the atomic orbitals that we have here that are taking part in the hybridization is D, plus we have the S, and we have 2 of the p orbitals. We have 2 of the p orbitals. So the hybrid orbitals that we are going to get is we have 4 atomic orbitals. So I will get 4 hybrid orbitals, and those orbitals will be called DSP2. So DSP2 is the name of the orbital, and we will get 4 of them. Now we will take an example. What are the compounds that form this type of what are the compounds which form this type of hybridization? So there is an example which is NiCl4, nickel, CN4 with 2 negative charge. Okay. Now there is something that you don't know right now, that is the oxidation state, है ना? But यहाँ पे आपको थोड़ा सा हम बता देते हैं. And in the redox reaction chapter, we will understand what is oxidation state also. So don't worry too much. We will just write it down, and when we do redox reaction, we will come back to this, and then we will understand this also more perfectly. So see, Cn, it exists as Cn negative cyanide. Okay, and we have 4 of them. So it will be, so we have X, right? This is nickel, whose oxidation state will be, whose charge will be rather X, plus we have 4 of Cn negative, and Cn negative have -1 charge. And the overall charge on this compound, it is equal to -2. So I can write X is equal to -4 will go that side, will become +4. So there will be 4 minus 2, and X will be equal to +2. So X has a charge, that means nickel has a charge of +2. As you know, for example, if I write about MgCl2, MgCl2. So we all know that chlorine will have -1 charge, and there are 2 chlorine, so 2 into -1. If I talk what will be the charge on magnesium, I can take this as X, which will be equal to the overall charge, which is equal to 0. So I can say X will be equal to -2 will go there and it will become +2. Now, similar is the case of nickel tetracyanide, and he have 2 negative charge. Now, since nickel has two positive charge here. See, now nickel 28, its electronic configuration is argon. Outermost electronic configuration is 4s2 3d8. Now we actually have nickel 2 positive here, so the nickel 2 positive will have an electronic configuration of argon. And please remember, the outermost shell here is the 4th shell, not the 3rd shell. 3rd shell is inside 4th shell, right? So it will be 3d8 only, 4s0 and 3d8. But please remember, the 4s is still present. 4s is having 0 electrons, but 4s orbital, 4s subshell is still present because the 4th shell is there, and 3d8. Now, if the 4th shell is there, so obviously the 4p will also be there, and it will be also having 0. 4p is there, even 4d is also there, but all of them are having what? All of them are having 0 electrons. Now, if I look at the ground state here, then in this what happens? We have the d subshell first of all, 1, 2, 3, 4, and 5. Then we have the 4s, and then we have the 4p. Now this is 3d, this is 4s, and this is 4p. Now in the 3d subshell, we have 8 electrons. So 8 electrons are something like this: 1, 2, 3, 4, 5, 6, 7, and 8. 6, 7, and 8. Now, as you know, we have here CN4 and we need DsP2 hybridization. So what will happen? This electron will not go and it will not do any promotion. Rather, it will pair up with the previous electron. So the excited state in this case is by pairing. Basically, what you need to remember is that this is going to have DsP2 hybridization. And then 12th standard, you will be doing this. It will be very easy in the 12th standard, but still listen this. 1, 2, 3, 4, 5, 6, 7, 8. And the 4s will be as it is. The 4b will be as it is. So from here, I will take one of the orbitals from the d, then s, one orbital, and 2 orbitals from the p subshell. So all of these will hybridize, and the hybrid orbital will become 4 of them, 1, 2, 3, and 4. All of these are vacant. Now Cn negative will come with its own electron. Cn negative. So Cn negative is having what? Negative charge. Why it is having negative charge? Because it has extra electron. So Cn negative, it will come with paired electrons. And it will give the electrons here, 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 and here. Okay, so this is a case of coordination bond. Okay, so you can please write this down and then write a few points. Now the nickel 2 positive, it will be having the hybrid orbitals. I think I need to draw this way. Nickel, it is having 2 positive charge, and these are the DsP2 orbitals. They will be in a square planar. Okay, so the electronic geometry is square planar. And if I put up the electrons, if I put up the Cn negative, then also nickel, the Cn will be here, here, here and here. And obviously this is also what? It will be having 2 negative charge. The shape is square planar. Is everyone done? Yes or no? Please tell me.
Yes, sir.
चलिए, आपकी तकलीफ यहाँ तक खत्म हुई. DSP2 का थोड़ा सा तकलीफ है ना, जो कि लाइक लिटरली स्पीकिंग यू डोंट ट्राई टू अंडरस्टैंड इट टू मच राइट नाउ, है ना. थोड़ी चीजें हैं जो आप बस याद कर लीजिए. फॉर एग्जाम्पल व्हाट यू नीड टू रिमेंबर इज डी ब्लॉक एलिमेंट्स. ये तो याद रहेगा. डी ब्लॉक एलिमेंट्स फॉर्म, है ना, एंड व्हेन द स्टेरिक नंबर विल बी 4, they can form DSP2, and they can also form SP3 and DSP2, and those are the cases that we are going to look into detail in the like the 12th standard. Okay, so obviously if your school master is like trying to set up a very tough paper, or if he is not very much concerned about what paper he is setting, he just sees a question and then puts it up, then maybe you can find this type of questions also. Okay, so DSP2 and the electronic geometry and shape, both of them are what? Square planar. So this is the small information that you have to just remember. Okay, you don't need to remember anything else, but it should be present in your notes. Okay, it should be present in your notes. Chaliye. Moving on, write the next topic that is important and आराम से समझ में आएगा आप लोगों को. Please write bond parameters. Write the topic bond parameters. Now in bond parameters, we are going to understand bond length. We are going to understand bond length. Wait a second. Okay, and one more will be there. So please write, we have bond length, we have bond angle, we have bond strength. ठीक है. There is one small topic that is bond order, but bond order ना फिर आप लोग गाली दीजिएगा केमिस्ट्री को, है ना, बोलिएगा पहले तो ऐसे बताए थे bond order, फिर वैसे बता रहे bond order. So in reality, bond order is a topic of molecular orbital theory, which we are going to learn at the end. Okay, we are going to learn about molecular orbital theory. In that we will learn about bond order, the true bond order, है ना, the true bond order. You are not seen in VBT, valence bond theory, Vesper theory. There is a bond order, concept of bond order, but that is what? That is not the new, not the modern concept. That is the old concept. So we will rather learn about the modern concept, जहाँ से सवाल आता है. And there only I will give you a bit of idea that how to tell the bond order with respect to valence bond theory and the Vesper and hybridization, these things. ठीक है. चलिए, in bond parameters, first of all, please write the bond length. What is bond length? We will write the definition and then we will understand it in detail. Right, number one, bond length. Bond length. Please write the equilibrium distance. The equilibrium distance between the centers of two nuclei of two bonded atoms in a molecule. Okay, please. So when we have a bond between A and B, now, if I have two atoms, A and B, and this AB is a molecule, then this bond is not a constant thing. It is just like a spring. Okay, it is like a spring. So A can move this way and that way. B is also moving this way and that. Now, obviously, equilibrium distance we are going to see. Now, we are going to see the equilibrium distance. That what is the average? We are not going to see the extreme, and we are not going to even see this extreme. There are two extremes, and in between we have a equilibrium, like the middle part. Now, so that we usually see what is the equilibrium distance between the centers of two nuclei of a bonded atom in a molecule. That is the definition of bond length. The more important thing is the factors that affect bond length. Right, next. Factors affecting bond length. There are two factors mainly. Factors affecting bond length. Number one is the size of atom. So obviously speaking, if we are having larger size of atom, the bond length will obviously be larger. Huh? So I can write bond length is directly proportional to the size of atom. And in that case, you can write, for example, if I have carbon-carbon bond, so carbon-carbon bond is going to be smaller than silicon-silicon bond. And further, the silicon-silicon bond will be still smaller than germanium-germanium bond. Huh? Because Cassie Geet Sunao Prabhu, if you remember this, right? Carbon, silicon, germanium, and then we have the later ones. So all of these are, they form predominantly covalent bonds. That is why we have compared these only. All of you understood this? Yes or no? Please tell me.
Yes, sir. Yes, sir.
Atoms, second is even simpler. That is the bond multiplicity. Bond multiplicity. What is bond multiplicity? बहुत खतरनाक term दिख रहा है. It is just the number of bonds. So single bond, double bond, and triple bond, that concept. Okay. So obviously bond length will be inversely proportional to the bond multiplicity. Imagine that we have a person, we have two persons, and both of them are holding hands, one hand, but okay. Both of them are holding one hand each. Now, if they have to hold two hands, then what is going to happen? They have to come closer. Yes or no? Correct, guys? So as we increase the number of bonds, then what is going to happen? Then the distance between those two atoms is going to decrease. If we have more number of bonds between two atoms, their distance will be even closer. Right? Yes or no? Understood, na? Anji?
Yes, sir.
So bond length decreases with increase in bond multiplicity. So I can write single bond का सबसे ज़्यादा होता है length. Single bond is longest, followed by double bond, not pi bond. There's a difference between pi bond and double bond. Pi bond is just one bond only, which is pi. But when I say double bond, it is one sigma and one pi, double bond. And even smaller will be triple bond. Okay, that is why I can say carbon, single bond carbon will be having the longest bond length, followed by carbon double bond, followed by carbon triple bond carbon. Similar is the case for nitrogen. So when you have nitrogen, single bond nitrogen, that will be greater in size than nitrogen double bond nitrogen, then nitrogen triple bond nitrogen. And also, if you have oxygen single bond oxygen, that will be longer rather than oxygen double bond oxygen. All of you got this? Yes or no? Please tell me.
Yes, sir.
Okay. Now, right, next. This is regarding bond length, right? So bond length, maybe I will put up a green. That will be more better. Now, second is bond angle. You have seen bond length. Now see bond angle. Please write. What is bond angle?
Sir, 1 second. Could you scroll up?
Yeah, sure.
Okay, sir. Thank you.
No problem. Now, in bond angle, please write average angle between the orbitals containing bonding electron pair around the central atom in a molecule. In a molecule. Okay. So why I'm saying again the average angle between the orbitals containing bonding electron pair around the central atom, it is because, let me show you why it is that way. Just a second. I don't know where you can see this or not, but let me try. This is a GIF, but I don't know whether it can be uploaded. It is uploaded, but it is uploaded as an image, I think. Yeah, no use. Just give me one more minute. This is happening as a let me know if you can see this.
Yes,
Can
sir.
you guys see the screen now?
Yes, sir.
Okay. Just forget about the names that they have written, but this is a water molecule. Okay. This is a water molecule. And as you can see, because there is slight temperature, now always we have at 25 degrees Celsius. So the atoms, they can vibrate. No? So all of these are what different types of vibration that we have. And we are especially interested in this one. Can you see the bond angle? It is changing. Yes or no? Please tell me. Okay. So
Yes, sir.
I think the oxygen atom is extreme this way. And if I go now, it is also here. Similarly, I think the extreme of oxygen atom is where? Here. I think here. So extreme, one extreme is here and the other extreme. Other extreme is here. So we can have two bond angles, right? The oxygen is still here. And the other angle can be this one. Okay, so let us suppose this is theta and this is phi. So obviously these are two extremes. So we will take the average of theta and phi. Got it, guys? Yes or no, please tell me. Anji.
Yes, sir.
Okay, so that is why we take the average. What about others? Sarah
Yes,
and
sir.
Harsha,
Yes, sir.
Yasir and Martin, all of you understood this? Why we take the average? Anji. Okay. Now, after this, we are going to look at the factors affecting bond angle. Please write. Factors affecting bond angle. So the number one factor is steric number. Steric number. Okay. Now you will write. Let us see what happens with the steric number. Okay. So I'm just writing things here. Steric number. And here we are going to write the hybridization. And I will write the bond angle. Normal bond angle. So steric number is if I have 2 sp and the bond angle is 180 degree. When it is 3, it is sp2. It is sp2 and it is 120 degree. Then we have 4 and this is sp3. This is 109.5 degrees, right? And then we have 5. This is sp3d. This is going to be, we are having 90 degrees there, right? The shortest angle that we have there is 90 degree. Then we have 6th one, that is sp3d2. Here we have 90 as well as 120, but still I'm writing 90 and 120. And the smallest is 90. sp3d2, all of them are 90 degrees. So can you say what is the relationship? As the steric number is increasing, the bond angle is, tell me guys, as the steric number is increasing, bond angle is decreasing, right? I hope all of you can see that. Now, there is one more thing that I can see. So all of these are fine. Don't write this, okay? Please don't write this now. We're going to look at even one more thing. That is the percentage S character. Percentage S character. Now, please see here. Here we have the hybridization as SP. So the orbital that are taking part in the hybridization, that is S and P. So the hybrid orbital will have 50% S character and 50% will be P character. You guys understood this? Yes or no? Please tell me. You have seen this in the electronegativity of different hybridizations. Yes or no? Correct. Anji, Harsha, Siddhika, Sara.
Yes, sir. Yes, sir.
We have seen this now. I think we have seen this.
Yeah.
In the last class only, I guess. See, the percentage S character, right? So it is 50 and it is going down. 50%. There we have how much? 33.33%. Here we are going to have 25%. And here we are going to have even less, right? I will have 5. Be 1 by 5 into 100. So I think this will be 20% now. Correct? This will be 20%. Now this will be 1 by 6 into 100. So 6 ones are, and then we have 3. Sorry, 6 ones are 6. Remaining is 4. So 6 threes are, right? 6 threes are 6 fours are 20. 40. Sorry, 6 6 6. So what is happening? Please see. As the S character increases, from 16 to 50%, as the S character increases, the bond angle is also increasing. Bond angle is increasing. Okay, bond angle is increasing. So we will write the relationship between two things: steric number as well as the S character. First of all, please write here the steric number or S character, both are the same thing. Okay, slash percentage S character. First of all, right? As the steric number increases, the bond angle decreases. And we'll write as the percentage S increases, the bond angle increases. याद रहेगा सबको? हाँ या ना जल्दी बताएं.
Yes, yes, sir.
Okay. Now, second point is the lone pairs. The lone pairs on central atom. Lone pairs on central atom. Now we will take a case and then you are going to tell me the conclusion. Okay. So we are taking the case of steric number 4. We are taking the steric number as constant and only changing the lone pairs. So we are taking the case of steric number 4. In steric number 4, we can have 4. Please don't write this. 4 sigma, 3 sigma plus 1 lone pair, and we can have 2 sigma plus 2 lone pair. Now, steric number, I'm going to take all of them. We will be having 4, 4, and 4 steric number. Now here we have bond pairs in the central atom only. We have how many bond pairs? 4. Here we have 3 sigma bonds, so 3. Here we have 2 sigma bonds, so there is 2 bond pairs. If I talk about the lone pair is 0, the lone pair is 1, and the lone pair is 2 here. All of them are the hybridization is what? Hybridization is still sp3. Here also sp3 because the steric number is 4. Here also sp3. Here also sp3. But if I talk about the angles here, the we are going to take a case. Wait a second. हमने बोला था लिखने के लिए नहीं ना, लिखना नहीं है इसे. Please see here. We're taking the case of CH4, and this will be NH3, one lone pair, and we'll be having H2O with 2 lone pairs. The bond angle in CH4 you have seen that is equal to 109.5 degrees, and this is equal to around 107 degrees, and it is equal to how much? 104.5 degrees. Correct. Now, what is happening? Tell me, guys. As the lone pair is increasing, as the lone pair is increasing, what is happening to the angle?
Decreasing.
Angle is
Decreasing.
right. So I can write bond angle. It is inversely proportional to lone pair on central atom. Lone pair on central atom. This is only when steric number is same. Okay, so first of all, we are going to look at steric number. Then we are going to look at the lone pairs on central atom. Is this clear? Yes or no? Please tell me.
Yes, sir. Yes, sir.
You see me write a question. Compare the bond angle of, we have NH3. इसको आप ले लीजिए A. Then we have NH4 positive. This is your B. And then we have C. That is NH. Sorry, उल्टा लिख दिया हमने. We have NH2 negative. Right, and right here C. ठीक है, तो सबसे पहले आप लोग steric number निकालिए. Calculate the steric number. You all guys have the formula, yes or no?
Yes, sir.
चलिए steric number निकाल के बताइए. What is the steric number for A, B, C? First of all, you will look at the steric number now. So let us see if the steric number is different, then we will classify using that only. Guys, please send me what is the steric number in the chat, please. Harsha, try once more. Last one, I think you are not right. Can you please send me how you have calculated for the last one? Yes, Sarah, correct. Harsha, can you please send me whatever you have done?
Yes, yes, yes.
Sorry. Say, Krishna, sorry, Harsha, that's fine. That's correct. So see, guys don't remember what is the steric number? See, steric number, it is equal to, steric number will be equal to 1/2, right, of the number of valence electron, right? Number of valence electron, that is followed by plus the number of monovalent, monovalent atoms. Then what do we do? Then we subtract the cationic charge, if we have any cationic charge, and we add the anionic charge. So if I talk about the first one, here we have the valence electron is how much for the NH3? 5 plus monovalent atom is 3, and there is no cationic, no anionic charge, and then 1/2 here. So 5 plus 3 is equal to 8. 8 by 2, that will be equal to 4. So steric number is 4 for NH3. For NH4, we have half. The number of valence electron is still 5, plus the number of monovalent atom, it is equal to 4. And we have a cationic charge, so -1. So 4 minus 1 will be equal to 3. So again, we are going to get 5 plus 3, that is equal to 8 by 2, that is equal to 4. This is also going to have steric number 4. Then we will look at the NH2 negative. NH2 negative is 1/2. 5 plus monovalent atom is 2, and the cationic charge is 1, right? It will be +1, na? Sorry, it will be +1. So it will be again 8 by 2, that is equal to 4. All of you got this? Yes or no, please tell me.
Yes.
This will be also 4. So with steric number, we cannot decide. With steric number, we cannot decide that what is the what do you say? What is the bond angle? Now we are going to look at the lone pairs. So obviously here we have what? Here we are going to have one lone pair. Rather, आप इसको छोड़िए. यहाँ पे लिखे bond pair. We will write the bond pair here, है ना? So we have we are going to have what? Yeah, steric number is 4. Bond pair will be equal to how much? 3, the number of atoms that we have. So right here 3, and here we have 4. So we'll write here bond. There will be 4 bonds. Here we have how much? 2. So we'll write 2. Then we will talk about the lone pair. So lone pair is just steric number minus the bond pair. So steric number is 4 and minus 3, that will be equal to 1 lone pair. Here we will be having 0 lone pair, and here we'll be having 2 lone pairs. All of you got this? Yes or no? Please tell me. Now you can just decide using the lone pairs. Sorry. Did someone say something?
No, sir.
Okay. So if I talk about the lone pairs, then we have maximum lone pair in the C structure, followed by A structure, and then followed by the B structure, right? And we have seen that bond angle is inversely proportional to the lone pair on central atom. So when I talk about the bond angle, I will just reverse it, right? C will be here, the sign will be reversed, A, and then the sign will be reversed and it will be B. So when we have large number of lone pair, the bond angle is small, right? That is why I just reversed the sign. All of you got this? Yes or no? Please tell me.
Yes, sir. Yes, sir.
Okay, write this down. Let me know once you're done. Everyone done?
Yes, sir.
Yes. Okay. Write another example. Carbon dioxide and CO3, 2 negative. Do this same thing. Steric number, bond pair, and then lone pair. Okay. You can, I think you are going to get in the steric number also. Maybe. I think in this you are going to get in the steric number only. Steric number will be different, so you will get the answer here. Someone has sent the answer. So A will be okay. Fine. Correct. Very good. So I think you got the steric numbers, yes or no?
Yes,
Steric number will be 2 and here it will be 3, right? Or if you got this, Sarah, Harsha. Sarah, you got this, yes or no?
I did a mistake in CO3 tomorrow.
If you did some mistake, okay. So stick numbers 2 and 3. So obviously the bond angle we have seen, it is inversely proportional to the steric number also, right? Therefore, steric numbers order is what? B is more than A. So the bond angle will be reverse of that. That means B will be less than A. Hanji. Chaliye. Moving on, right next. Write this quickly. Third is electronegativity. उल्टा कर लिया. Steric number तो ठीक है. We are comparing the bond angles ना सिद्धिका.
Yes,
सिद्धिका,
sir.
है ना? So
Yes.
bond angle will be the reverse of the steric number, right? Because we have seen as steric number increases, bond angle decreases. Okay, so please correct
Yes,
that.
sir.
Bond angle will be A is greater than B. Now,
Okay.
in the same sequence, third factor that is going to affect is the electronegativity. Third factor is electronegativity. That is chi. So please write. Now, when we are looking at electronegativity, we have to look at two different cases. Okay, one is the electronegativity of central atom and electronegativity of surrounding atom. So please see what if central atom is different. That means surrounding atom is same, but central atom is different. Central atom is different, but the surrounding atom is same. Then what is going to happen? The bond angle will be directly proportional to the electronegativity of, my bad, central atom. ठीक है? Electronegativity of central atom. जो different है उसी को देखना है ना? Please remember guys, whatever is different, we are going to look at that only, because if something is same, that is not going to change the bond angle. है ना? Now, if we are having surrounding atom is different, but central atom is same. Now, bond angle, it is inversely proportional to the electronegativity of the surrounding atom. Electronegativity of the surrounding atom. Now we are going to understand this with two examples. One we will take the central atom different, and the other we are going to take as the surrounding atom different. Okay. So write this down, then we will show why the bond angle is directly proportional to the central atom if the central atom is different, and why the bond angle is inversely proportional to the surrounding atom if the surrounding atom is different. All of you got this? Yes or no? Please tell me.
Yes, sir.
All of you wrote
Yes,
this down?
sir.
Can we move? आगे बढ़े?
Yes, sir.
चलिए.
Yes.
Now please see. Don't write anything. Please see. First of all, we are going to look at NH3 versus PH3. Next case, we are going to look at NH3 versus NF3. So tell me what is different here, central atom or the surrounding atom? In NH3 and PH3, what is different? Anji, what is different? The central atom is different or the surrounding atom? Sorry, Harsha?
Central atom.
Very good. Central atom is different. I hope all of you can see here the central atom is nitrogen, and here we have phosphorus. So central atom is different and surrounding atom is same. Now let us see. Both of them will have structure like this. NS3 with one lone pair. Similarly, the PH3 will also be having similar structure, PH3 with 3 hydrogens and one lone pair. But now listen very carefully. Okay, now listen very carefully. Here, the nitrogen is more electronegative, right? The nitrogen is highly electronegative, so it will pull the electron towards itself, and the shared pair of electron between nitrogen and hydrogen will be predominantly near nitrogen. Correct, hey guys? Yes or no? Please tell me. Is it correct? Yes or no? All of you tell me.
So can you repeat?
Okay, I am saying since nitrogen is more electronegative, it will pull the electron towards itself, and the shared pair of electron between nitrogen and hydrogen, they will be near to nitrogen, right? They will be near nitrogen rather than hydrogen, because it is more electronegative. It is pulling the electrons, right? Harsha, Siddhika, Martin, Yasir, Sara. Anji, Sara?
Yes.
Sara got it? Okay, now. But if you remember the electronegativity series, phone, call, bro, ishq, pyar hai, ishq, pyar hai. Phosphorus and hydrogen, they have almost equal electronegativity. And obviously, phosphorus is not as electronegative as hydrogen, sorry, not as electronegative as nitrogen atom. That is why the electrons will be almost in the middle. Now, as you can see, what is happening with the nitrogen's electron is that they are near nitrogen, and that is why the distance between the electron is also getting smaller. The distance between the electron is getting smaller, so there will be more repulsion. There will be more repulsion between the nitrogen's bond pair electrons because they are near nitrogen and they are nearby each other. That is why they will pull both of these apart. Right? So it will be pulling all the bond angles apart, because what is happening? Because there is repulsion, because they are near. Okay, so what is going to happen? The bond angle will be greater here. And that's what we have seen. If the central atom's electronegativity, the bond angle is directly proportional to the electronegativity of the central atom. As you can see, nitrogen is having more electronegativity and the bond angle is also greater, because when there is more electronegativity, electrons come near nitrogen, there is repulsion and they're pulled apart, making the bond angle higher. All of you got this? Yes or no? Please tell me.
Yes, sir.
Yes.
Now let us look at the case of, if you have not understood now, then please like say properly, okay? Like turn your mic on properly, don't use spacebar when you have not understood. Okay, now see NS3 and NF3. Tell me guys, what is different here? Surrounding atom or the central atom?
Surrounding atom.
Surrounding atom is different. Surrounding atom is different. Central atom is same. Now, in the both the cases, nitrogen, hydrogen, hydrogen, and hydrogen. Here you have nitrogen and fluorine, fluorine, and fluorine. Now, again, nitrogen is more electronegative, right? So nitrogen's electrons will be here like this, right? But here, who's more electronegative? Fluorine is more electronegative. So fluorine electrons will be like this. So where can you see more? Where are the electrons more near? If you look at the bond pairs, where it is more near, A or B? Where it is more near, A or B?
A.
A, it is more near. So there will be more repulsion, correct? There will be more repulsion in A and the bonds will be far apart. So again, here NS3 will be having greater, NS3 will be having greater bond angle than NS3. Now, it is not because of nitrogen. It is because of the fluorine. The fluorine is more electronegative. That is why it is pulling the electrons away from nitrogen. Now the electrons are already very far away. So there is less repulsion and the bond angle is smaller. And as we have seen, if I talk about the surrounding atom, then if the surrounding atom's electronegativity is higher, the bond angle will be lower because they are inversely proportional. All of you understood, you got the relationship and understood why it is happening, yes or no? Please tell me.
Yes, sir.
Okay, now you can copy this down. Let me know once you are done.
Done, sir.
All of you done? Yes or no? Please tell me. Anyone still writing?
Yes, sir. 1 second.
Okay, please write. Those who have written, they can write the topic. Next topic is you can call it bond energy. You can call it bond dissociation energy. You can call it bond enthalpy. All of these terms, they give an idea about the bond strength. It gives an idea about bond strength. Okay. Now, please write the definition. See, bond energy is what? Bond energy is typically like the amount of energy required to break a bond. But breaking one bond is very difficult. Huh? How I will take one molecule and break one bond. So we generally break 1 mole of bond, and then we call that as a bond dissociation energy or bond energy. So please write the amount of energy required to break 1 mole of bonds of a particular kind of a between 2 atoms in gaseous state is called bond dissociation energy. And bond strength, jitni zyada energy lagegi, more the energy required for the breaking of a bond, higher will be the bond strength, stronger will be bond. So bond strength is directly proportional to the bond dissociation energy. Now, as we are moving, factors affecting BDE. Factors affecting bond dissociation energy. Factors affecting bond dissociation energy. First of all, size of bonded atoms. Number 1. So obviously here, the bond dissociation energy, it is inversely proportional to the size, because jitna size bada hoga. So for example, if I have 2 bonds like this, so the bond here, the electrons which are bonded here, these are very near to the nuclei, and the nuclei is attracting. What is actually happening? Please see. We have the nucleus here, we have the nucleus here, right? And then we have electron density here. So that is the bond. So how the 2 atoms are together, please see. See, this positive charge is attracted towards the electron in this way. This positive charge is attracted towards the electron in this way. And that is why the 2 atoms that we have, they are bonded. That is why the 2 atoms that we have, they are bonded. Now imagine that we have large size of atom. If you are going to have a large size of atom, then obviously the nuclei will be very far apart, right? And the valence shell electron will be also far apart, and there will be electron density here. Now you can see it's obviously going to be very weak bond because the nucleus is far away and the nucleus is attracted towards this far away electron. This nucleus is attracted towards this far away electron. So it will be very easy to break these bonds because the nuclei and the electrons which are taking part in bond formation, they are very far apart. So bond dissociation energy is inversely proportional to the size of atom. So as size of atoms increases, bond dissociation energy decreases. Second is bond length. Second is bond length. And same thing. If you have a larger bond length, it will be easier to break. So bond dissociation energy is inversely proportional to the bond length. Third is bond multiplicity. In bond multiplicity, what actually happens? The bond dissociation energy, if I have more bonds, it will be difficult to break those bonds. Right? So bond dissociation is directly proportional to the bond multiplicity. Directly proportional to the bond multiplicity. All of you got this? Yes, no, please tell me.
Yes, sir.
Okay.
Yes, sir.
Now, write a question. Compare bond dissociation energy of following. We have number A, carbon single bond carbon, carbon double bond carbon, carbon triple bond carbon. This is what we can write 1, 2, 3, which is the strongest bond. Then compare HF, this is 1, HCl, 2, HBr, 3, and HI, 4. Asha, you send the answer ना वो अच्छे से बना के भेजिए 1 ज़्यादा 2 ज़्यादा या 3 ज़्यादा like with the arrows and everything. You can send me on WhatsApp. Okay. If it is difficult to send on the chat, you guys can send on WhatsApp also. Oh my God. इतना आसान सवाल है यार, इतना टाइम क्यों लग रहा है आप लोगों को? So here what is different guys, tell me. We have what factors? Factors देखिए पहले ना. What are the factors that affect the bond association energy? We have the size. The size, check whether it is going to be same or different. Then we have the bond length. And then we have the bond multiplicity. तो साइज तो सारे कार्बन एटम्स का सेम होगा ना, ऑल द साइज विल बी सेम. ये सारा करेक्ट, वेरी गुड.
The second one also is same like one first one, right?
नो, सेकंड वाले में देखिए आप, सेकंड वाले में साइज अलग है ना, क्लोरीन का, ब्रोमीन का, आयोडीन का, राइट. So in the A case, it is going to be third one will be having the highest bond association energy because it will be difficult to break. इसका bond multiplicity क्या है, ज्यादा है, right? Also bond length is smaller if you have triple bond. But if I look at the B one, please see here we have fluorine, chlorine, hydrogen is same, so we are not going to look at hydrogen. But what about fluorine, chlorine, bromine, iodine? So the one which is larger, that is when the size increases, what happened to bond association energy? Bond association energy decreases because it is inversely proportional. So iodine has a larger size, followed by bromine, followed by chlorine, and then followed by fluorine, right? That is why the HF will be strongest, followed by HCl and HBr, and then HI. All of you got this? Yes or no? Please tell me.
Yes, sir.
Harsha, looking at your answers. 8, 1, 1, 2, 3, 4, 5. ठीक है, correct Harsha, very good. Now, right next, dipole moment. This is not one of the bond parameters, but it is a topic of its own. Right? Dipole moment. Dipole moment, you will study it also in physics in the next class, 12th class. Okay. So right now your physics is completely revolving around point mass. Correct? Yes or no? Harsha, Siddhika, Sara, Martin and Yasir. Point mass. नहीं. अंजी, अरे नहीं. Point mass नहीं पढ़ा आपको. Harsha?
Mass with a constant value.
No, I mean, for example, if I talk about Earth, then I don't talk about the complete Earth. Na? I take the Earth core. For example, even if you talk about gravitation of Earth, so why do we take the force of gravitation is equal to G m of Earth and m of object divided by r square? Why the distance between, see the distance between Earth and the object. For example, if I talk about my pen that is here, 1 meter above the Earth's surface, then the actual distance between Earth and the object is what? 1 meter. But why do we take the r, the radius over the Earth? Because we assume Earth to be a point mass. So we have the Earth here, so center of the Earth is here, and we assume that complete mass of the Earth is it is on the center, and then we calculate the distance from the center to the object. Now, obviously, approximately the complete distance from the center of the object is the radius of the Earth. That is a very large number, some thousands of kilometers. And then if you add 1 meter where I am placing my object, that is not going to make any difference, right? That is why we take the distance from Earth to object as what? As the radius of Earth and not the actual distance. लेकिन अगर आप actually देखें, what is the force of gravitation? Universal law है ना, G m1 m2 upon the d square, distance square. So 1 meter क्यों नहीं लिया, radius क्यों लिया? Because we are assuming the Earth to be a point mass. ठीक है, अच्छा चलिए हम ये बता दिए फिजिक्स के बारे में. Right now your physics is revolving around the point mass. That if you are moving this way, so everything is regarding mass. In the 12th standard, everything will revolve, like not everything, but most of the chapters will revolve around point charge. Okay, so you have positive charge and negative charge, right? So that is the dipole. What is a dipole? When you have two poles. Poles means poles apart. Positive and negative, right? Positive and negative. So this can be plus 1 charge and 1 negative. It can be 2 positive charge, 2 negative charge, 3 positive charge, 3 negative charge. So when we have 2 charges separated by a distance, it creates a dipole. What is dipole? 2 charges separated by distance. All of you got this? Yes or no? What is dipole? Dipole is 2 charges separated by distance. Are bolo bhai. What is dipole? Dipole is 2 opposite charges. Kar le zyada better hoga. 2 opposite charges
Opposite charges
separated
separated.
by distance. Okay. Also, one more thing: 2 same opposite charge. Magnitude will be same. If it is +1, it will be +1 and -1, +2 and -2. And the amount of dipole that is present, that is measured by dipole moment, which is given by mu. So the mu, it is equal to the charge multiplied by distance. The charge multiplied by distance. This is dipole moment. Okay, mu is what? Mu is the dipole moment. Chaliye. Next thing that is important is the dipole moment is a vector quantity. I hope vector quantity आप लोगों को पता होगा, yes or no?
Yes.
Okay. Now, when we will talk about the dipole moment, then we are going to talk about 2 different types of molecules. We have diatomic molecules and we have polyatomic molecules. Okay, so please write next. In diatomic molecules, the mu depends only on the electronegativity difference. Got this? Yes or no? Please tell me. Only depends on what? Only depends on the electronegativity difference. Therefore, if I compare na HF, HCl, HBr, and HI. Now, in this case, what is going to happen? The HF is going to have, see, fluorine is most electronegative now. That is why it will have a higher delta negative, a higher delta positive. So the Q is very high. If the Q is very high, then the dipole moment will also be very high. That is why what happens? HF is going to have the highest dipole, followed by HCl, followed by HBr, and then HI. But in polyatomic molecules, please write in polyatomic molecules, the mu depends on the mu. It is going to depend on the vector sum of dipole moment. Depends on the vector sum of dipole moments of all covalent bonds. ठीक है, तो ध्यान से देखिएगा जरा. Please see here very carefully. For example, I am taking an example of, let us suppose, NH3. क्या दे रहे हैं? NH3. So you have nitrogen, 3 hydrogens like this. And a lone pair here, right? Now, what is more electronegative between nitrogen and hydrogen? Nitrogen is more electronegative, right? So nitrogen की तरफ एक dipole हो. That means this is going to have delta negative. This will be delta positive. So positive to negative dipole बनेगा इस तरह से. उसी तरह से nitrogen, sorry, hydrogen to nitrogen, there will be a dipole like this, pointing towards nitrogen. There will be a dipole from this hydrogen to nitrogen, pointing towards nitrogen. Now, there will be a dipole from nitrogen towards the lone pair also. Nitrogen towards the lone pair also, because lone pair is what? Lone pair is more electronegative, na? एक इस तरह से dipole होगा. All of you got this? Yes or no? Please tell me. ठीक है? So the net dipole moment, if I talk about, if I take the complete sum, it will be upwards only, right? So the net dipole moment, I can say that the net dipole moment is upwards. Oh, you ulta ban gaya, my bad. Net dipole moment will be upwards. All of you got this, guys? Yes or no? Please tell me. Yes or no?
Yes, sir.
अब देखिए
Yes.
दूसरा एग्जांपल जो है, let us suppose we have nitrogen like this, and then we have fluorines attached, right? The nitrogen will have lone pair here like this. Now, if I talk about the nitrogen fluorine bond, so dipole will be like this, correct? Yes or no? Directing towards fluorine, because fluorine will be delta negative, delta negative, delta negative, because it is more electronegative than the nitrogen atom. हाँ जी बताएं, yes or no? Correct
Yes,
है?
sir.
Now there will be one dipole moment, rather one dipole moment pointing upwards for the nitrogen, from nitrogen to the lone pair electron. Correct? Now there are dipole moments which are pointing downwards, and there is a dipole moment which is pointing upwards. So some of the dipole will cancel out, yes or no? Some of the dipole will cancel out, and essentially जो आपके पास dipole moment बचेगा, that will be only some of the dipole will be left, right? Maybe upward, maybe downwards. Have to look at the values. Let us suppose it is downwards, right? Or even if it is upwards also. But we can see that some cancel here, no cancellation. Here cancellations, right? Downward dipole, it cancelled the upward dipole. That is why we can say that the dipole moment of NH3 will be greater than the dipole moment of NF3. All of you understood this? Yes or no? Please tell me the dipole moment, how to determine.
Yes, sir.
Okay. Now, right next. For example, if you have CCl4, then you have CHCl3, then you have CHCl2, then you have CH3Cl. Now, chlorine is more electronegative, so their dipole will be from carbon to chlorine, carbon to chlorine, carbon to chlorine. Now, here we have 4 chlorine. All of the atoms that are bonded to carbon, it is chlorine. So all the chlorine atom will be cancelling each other. So this dipole moment here, it will be actually net 0. A dipole moment here, it will be equal to 0. Now here there are 3 chlorine atoms. So some of the chlorine will be cancelling the other chlorines. Here we have 2 chlorine atoms only. So there will be some chlorine atom which are cancelling, one chlorine atom cancelling the other. Here we have 1 chlorine atom. There will be no cancellation in CHCl3. We will be having 0 cancellations. That is why it will be having the highest dipole, than this and then this. Understood this? Yes or no? Please tell me.
Yes, sir.
Now, after this, let us see an example, that is H2O versus H2S. Now, in this case, the dipole moment, it is going to depend on, see, if the surrounding atom is what it is same, and if you are having, if the surrounding atom is same and the central atom is different, then we are going to look at the electronegativity of central atom. So since electronegativity of oxygen is more than that of sulfur, we will have more dipole moment on H2. So we'll write H2O has higher dipole moment as the electronegativity of oxygen is greater than that of sulfur. Now, I am going to give you a sequence how to check the dipole moment, how to check the dipole moment, and where you can see that the dipole moment is 0. Where you can say that the dipole moment is 0. देखिए एक तो सबसे पहले आपके पास केस बन जाएगा. Please see. If I talk about determination of dipole moment, then there will be one case, that is स्टार्टिंग में 2 केस रहे, 2 केस रहेंगे। सबसे पहला यहाँ पे 0 लोन पेयर्स, 0 लोन पेयर्स, ठीक है। Now if you are having 0 lone pairs, then you will check after that all surrounding atoms are same. All surrounding atoms are same. If yes, if all the surrounding atoms are same, if all the surrounding atoms are same, then mu is equal to 0. है ना? For example, as you can see, CCl4, carbon is not having any lone pair electrons and all the surrounding atoms are same. That means dipole moment 0. But if you look at NH3, here we are having lone pair electrons. So even if you are having the surrounding atoms are same, even then there is a dipole moment because there is a presence of what? There is a presence of lone pair electron. Okay, so please remember that also. So if there are 0 lone pairs, if there are 0 lone pairs and all the surrounding atoms are same, then the dipole moment will be 0. If this is not the case, then we can say that the dipole moment, it is inversely proportional to the number of same surrounding atoms. जितना ज्यादा surrounding atom होगा उतना dipole moment कम होता जाएगा ना. The dipole moment will be smaller, as you can see here. CHCl3, CHCl2, CH3Cl. In this case, we have 0 lone pair, but the surrounding atoms are different. Surrounding atoms are different. And in this case, you can see, अच्छा यहाँ पे एक चीज और लिख सकते हैं, number of same surrounding atom with higher electronegativity. Chi is, this is for electronegativity, you know, with higher electronegativity. So as you can see here, we are having 3 chlorines. Which is more electronegative? You are going to look at that atom. Surrounding atoms are hydrogen and chlorine, but I will look at only chlorine because chlorine is having higher electronegativity. Here we have 3 chlorine. Here we have 2 chlorine. Here we have 1 chlorine. So inversely proportional, less number of chlorine atoms will be, the dipole moment will be higher. Small the number of surrounding atoms, higher will be the dipole moment. Understood this case? Yes or no? Please tell me. Hanji, बताएं. All of you got this? Yes or no?
Yes, sir.
ठीक है. Now let us suppose there are some lone pairs. One or more than one lone pair. Now, in this case, we are going to look at 2 different cases. Whether the surrounding atom is same or like whether the surrounding atom is different or the central atom is different. Okay. Let us suppose we are having surrounding atom is different. Surrounding atom is different. Now, if the surrounding atom is different, then you are going to look at the electronegativities. Surrounding atom is different. Okay. In this you can write, इसमें भी 2 केस बन जाएंगे. Now it is going to get complicated, I think. If the chi of surrounding atom is greater than chi of central atom, chi of surrounding atom is greater than chi of central atom, then what is going to happen? Dipole moment will be inversely proportional to the number of surrounding atoms. If you have more surrounding atoms, the dipole moment will be lower. Next case is if you are having the chi of surrounding atom is less than the chi of central atom, then in that case, the dipole moment will be directly proportional to the central atom, surrounding atoms. If the surrounding atom is different, then you are having two cases. If surrounding atoms की electronegativity is higher, then the dipole moment will be inversely proportional to the number of surrounding atoms. If the electronegativity of central atom is higher, then the dipole moment will be directly proportional to the number of surrounding atoms. Now let us see the case if you are having central atom difference. Here also we can have two cases. If you have the chi of surrounding atom is greater than the chi of central atom, then in that case, what we can say? Chi of surrounding atom is greater than the chi of central atom, and the central atom is different. pH3, NH3. So the dipole moment, surrounding atom का ज़्यादा, तो dipole moment you have more fluorine. Will be directly proportional to chi of surrounding atom or the number of surrounding atom. It will be directly proportional to the surrounding atom. And if the chi of surrounding atom is less than the chi of central atom, then let us see that case. Chi of central atom is greater. So you have pH3 versus NH3. In this case, the nitrogen oil. So you can say that the dipole moment is directly proportional to the electronegativity of central atom. यहाँ पे भी आप dipole moment is directly proportional to the electronegativity of central atom. Oh, sorry, surrounding atom. In part here. Okay. You can have this chart. That's fine.